Good morning, everybody. Welcome to the Marubeni CITIZEN Cincom Print to Part Demo Day. I'm Scott Laprade, Technical Supervisor with GenSwiss.
And I'm Vince Antignani, Applications Engineer with Marubeni Citizen.
We've got an exciting program put together today, probably for over the next 60 minutes or so. We're going to go over some of the tools that are used and the reasons behind selecting certain tools for a relatively simple part for the Citizen L20E-3M12B5 ATC.
Yep.
And Vince, what are you going to go over?
Well, mostly the machine, a little bit about the part, and a little bit about the process of how we, bring the part from our print to our process.
Excellent. We're going to go down some of the latest and greatest tools from GenSwiss as well. So we're going to cover some of the OD turning, some of the grooving, some of the tools that you might commonly see out there on the shop floor whenever you're running a part of this nature. The part itself has been designed in such a way so that it covers a lot of bases. We got some threading, we've got some grooving, we got some OD turning. We utilize the B-axis, we utilize the ATC, and we'll go over the tooling that's involved with each of those steps. So with that, why don't we roll right into the drawing? Let's get that called up.
Let's see this part.
Hold on 1 second. There's no sound. Oh, shoot.
There we are.
Right.
So this part is actually a very nice part for this type of equipment. You can see that the major diameter on it is right around 1/2 inch. So it's a really good one, right in the middle of the wheelhouse for the Citizen L20. You can see that we're starting it off with some threads on the left-hand side there. We've got OD grooves, 45-degree angle cross holes, and then we've got some interesting back turning as well for the subspindle side.
Right, and one thing that you end up, whenever you're going to design a process, the first question that you have to ask is which side is the front, and the B-axis features, as well as that 1/2 inch diameter, very close to what I'm going to call the back end, make it a fairly obvious choice that I want that longer thread to be the front in this case. We could approach it from the other side with an overgrip collet or things like that, but honestly, I feel like that's overcomplicating what doesn't need to be that crazy of a process. Now, when we watch the video of the part being run, anyone who's more used to conventional machining will notice some very drastic differences from the way they would normally do a part. You're going to see that, for one, in the Swiss world, we're not going to do a lot of roughing and then finish. We're just going to hog it all out to the full depth of cut because that's how we roll, and we could do that thanks to the guide bushing supporting the work right where the cut is happening. As a consequence of that, though, you're also going to see a lot of indexes where you normally wouldn't index. I'm sure a lot of the conventional lathe guys would just turn that OD first and then come along, well, rough it obviously, then turn it to finish, and then come along and make all the grooves and change tools only as the operations change. But in Swiss, you only have a little bit of guide bushing land to work with, so you have to do some indexes where you normally wouldn't. You have to section out the parts in roughly 3/4 inch segments just so you make sure you maintain that rigidity and you're not coming out of the guide bushing.
I can tell you right now, I've been doing this for about 20 years now, selling tooling for CNC Swiss lathes, and it's really all that I know. I don't really, I'm not terribly familiar with other styles of machining. This is the thing that I learned on. And we get a lot of new operators that maybe did come from the lathe world, and they don't understand the whole full depth of cut thing. I'll be troubleshooting their problems. They'll be telling me, oh, I'm getting a little bit of a finish issue here, or why is my part not holding tolerance? And I start talking about their machining strategy, and they're doing roughing and finishing passes. And that's not our goal here. We're trying to do full depth of cut all in one shot. So a lot of the tooling that's up on the screen right now is aimed specifically at that. We've got an ISO style front turn operation. We've got our Cut 3005 tools, which are a derivative of the original Swiss style turning tools from over 100 years ago. These are the modern iterations of them that we're using now with the latest and greatest equipment. And we'll get into some of the details of why you should choose some of these for the specific features on this workpiece.
Yeah. With that in mind, are we ready to see some chips?
I think we're ready to see some chips. Get that video up on here. Run the part process. So we start the process off with a facing operation, obviously, and we're going to use a simple DCGT for that. You can see in the video there, all the holders are set up for coolant through. High pressure coolant is a pretty standard thing in the Swiss style machining world these days, but we're using it in brass so everybody can actually see what's going on.
Right, don't want to flood the window, and then nobody can see.
Yeah, exactly. So normally this part would be a 303 stainless part. So the geometries on these tools are also very conducive to materials of that nature. The CITIZEN GenSwiss multi-deck series of tools is really aimed at your stainless steels, your titaniums, and we're starting to get into some of the high-temp alloy type stuff too. But for today, we're going to run brass.
Right, and you're already seeing some of that segmenting of the part. We turn the first OD, and then when we came in to do the threading, you noticed those retractions of the thread. We made sure that they didn't pull out of the guide bushing when we did that, and if we turned the full diameter, every single time we retracted to make another thread pass, that thing would be kicking like a mule as it tried to re-enter the guide bushing, probably ruining your cut.
That's the thing that I always tell new users. You got to make sure that it doesn't fall out of the guide bushing or you're going to have a bad time. Now we're doing a little bit more of an OD turn here on the rest of the part.
Right, and then the groover's going to come back in and finish up some of those, some of those features on the wider OD there.
So what we got really simulated here is this thing's kind of supposed to be like a hydraulic control valve assembly, basically, is what this thing's supposed to look like. So we're putting in some of these grooves. These would be potentially for like an O-ring in the final assembly, something like that.
Right, exactly, and then we're going to be, putting spotting some holes in those grooves, drilling some holes in there, and now we're going to see our first tool change on the ATC. We have a 4-second chip-to-chip time in cycle. On the prep page, it's slowed down a little bit for safety. And then the angled work here is actually really simple. The Citizen platform makes it extremely easy to program what looks like a complex operation. We'll see at the end of the cycle some of what the actual code for the B-axis looks like as far as the drill goes. It really is that simple. There's a lot of codes in there where it's a right tool for the right job approach. So as long as you know what you want to do and you set the machine in the mode for what you want to do, you basically just give it print dimensions and the machine takes care of the rest.
Yeah, we were talking about that off camera a little while ago, and you were explaining it to me, Vince. You see the axes moving in conjunction there. That's pretty intimidating to somebody who's new to the Swiss world. They see that and they're like, how do I program that? And Citizen's done such a wonderful job of making it really easy to achieve complex features like that.
Oh, for sure. Like when we see the code, you'll see it's just a normal face-op. Anyone who's ever drilled a hole in the middle of their part, it's going to look very familiar to them.
Mm-hmm.
And here we're just wrapping up at this point.
Yeah, kind of prepping it for pickoff at this point here. So the rest of this is going to be blanked out for the subspindle work. So again, we came in with our trusty DCGT, and now we're going to part it off with the brand new state-of-the-art Cut 5000 series from Utilities. We'll get into some of the details of that in a little bit.
Yeah, sharp-eyed viewers might have already noticed the coolant through port underneath next to the insert.
That's it right there. We want to point that out. That's part of the IC Plus series.
Other sharp-eyed viewers might have already noticed that some of the inserts used on these backworking tools are the same ones that were used for similar work on the front, the turn and the groover specifically.
I'm glad you brought that up, because that was one of the main reasons I had chose these particular modules for the subspindle, just to show some of the simplicity, because that's one of the mottos at GenSwiss, is to make it easier for the machinists on the shop floor. So when you pair GenSwiss tools with a Citizen machine, you have a real good recipe for success.
Yeah, absolutely. And now we're just finishing up that thread. We're going to use that the slots on the cross with the tie lock extended end mill there.
That's one of my favorite products right there. That one's one that we actually engineered specifically based on customer demand. And you can see why you would need it in a machine like this, because the tooling layout, you've got your subspindle collet in there, you've got small tools, you have clearance concerns, and the tie lock is really just a nice rigid extension that gives you a place to install micro end mills to engage the workpiece without flex and deflection, and it also enhances the tool life.
Yeah, I absolutely had clearance concerns there. If you're looking real close, you could see that if I didn't have that extension there, those two cat nuts would have absolutely kissed there and made what Scott describes as a very expensive noise.
Very expensive sounds is what we want to avoid.
And I honestly, with the tie locks, I love how simple it is to change a tool. And the rare time that I break one, I just undo the set screw, put it right back in against the backstop, and I'm touched off again at exactly the same place I was when the first tool broke.
There we are. There's a full cycle. So, recap of everything that we did there. We've got our Cut 3000 series threading, Cut 3005 grooving, 5000 series part off with internal coolant, and then we got our subspindle work and our ATC work. So that's the all the tooling that was used in a nutshell right there. So I think probably the next thing to show would be we can kind of get some up close with some of the tooling. So we've got it all laid out here in front of us, and this is all the exact stuff that was utilized in that setup. So we kicked it all off with the what we call the multi-deck ISO tools, and this is your traditional style front turning geometry DCGT. But the thing that I always like to highlight on this is from GenSwiss and Utilities, we're Swiss specialists, so the edge conditions on all these are very sharp. Our whole selection is very small nose radii, and they're high positive chip control geometry, which works very good with a lot of the materials that you encounter in the Swiss machines. They're very good for removing that material when it's long and stringy. It gives you a good chip control. And then we moved on to the Cut 3000 series tools. So this is a series that I chose specifically to use on the L20 because this is our workhorse series from the multi-deck line. This series of tools goes from theoretically the smallest parts you might want to turn, but it works really, really well in that 15 to 20 millimeter diameter. There's a lot of geometry that's all available for that. And going hand in hand with the idea of making the machinist's life easier on the shop floor, it's a one-holder system. So if there's one thing that I want you to take away from the tooling side of this presentation, it's that the multi-deck cut series tools use one holder for all the different geometries. So all the different operations that you saw us just do in that turn, you could do with one holder, whether it's a right hand or a left hand. That's the only thing you got to match up is left hand execution, right hand execution. But other than that, you can do grooving, front turning, threading, back turning. We even have full radius tools right out of the catalog ready to go. So if you got things like O-ring grooves and things like that, you know, nice easy stuff that you can choose right from the catalog.
Is that a 15 taper next to the...
This sure is. So sharp eyes might pick up on that as being the ATC tool. So this is from GenSwiss. We've actually been working with our friends here at Citizen to develop the tool holders themselves for the ATC. So this is probably one of the prototype models, I believe, but we're only a matter of weeks away from having saleable product. So going forward, if anybody's looking for additional tooling for the ATC setup, we're going to have this on the shelf ready to go.
That's awesome. I can't wait to try one out. And then, what do you got next? The cutoff?
The cutoff. The cutoff was the other big one. So we moved into this when we did the part-off operation, and at first you might look at this and go, well, this doesn't look anything like any of the other tools that you're working with, because the Cut 3000 series tools we did, you can do part-off with that as well. But the reason we introduced this is it's got what we're calling our new IC Plus, which, if you can look closely there, actually has an internal coolant jet that goes into the groove alongside the insert. And what that flank cooling does is evacuates chip and keeps that carbide edge cooler for longer when you approach center line of the workpiece. Because as you approach center line of the workpiece, your heat spikes because of the surface footage is falling off. That's where most of your damage occurs to the coating and to the carbide substrate. So by internally cooling it while it's in the cut like that, it does a remarkable job of evacuating heat and keeping chips free from there. So your tool life just goes up significantly.
Yeah, I really couldn't believe the improvement to tool life. It practically doubled.
It's a type of a solution that's been out there in the general lathe community for a long time, but what makes this one special is we go down so very small now. Now it's in a Swiss size package. It kind of dovetails really nicely with the high pressure coolant pumps that are commonly delivered pretty much right out of the box these days. I remember when I first started doing Swiss style tooling, the high pressure pumps were kind of an option, but it's very rare that I ever encounter anybody who doesn't have one installed. So they can make full use of the benefit of the internal cooling holders that we've developed with our partner Utilities.
Yeah, that actually dovetails nicely. I was about to appreciate the ports on the side here because those do mate with the slots that are starting to come standard on all of our Swiss gangs. We have slots built into the gang plate, which I don't know if you'll see on the camera. Oh, here's one. So in each of the tool pockets, you have a slot that is plumbed from the rear for coolant through. And so when you have you're not adjusting, yeah, there's a great picture of the gang in the machine with your new Cut 5000 in there. And when you're no longer just sitting there struggling to bend brake lines and trying to angle some jets that are going to move the next time you index a tool and it gets bumped, or
Yep.
when you come in for your pick off or something like that. No, you just open the port on the holder, align it with the slot in the gang, clamp it down, and whatever line is plumbed there just gets coolant right through the tool.
Yep. And you think about, again, that overarching theme of trying to make it easier for the guy on the shop floor. I've had customers come to me before and they say, setting up my high pressure takes as much time, if not more time, than actually touching off and setting up all my tools. So imagine right out of the box, you have this coolant through capability that's left semi-permanent in the machine, and now you just interlock your tooling and you deliver it right up to the cutting edge. That saves a tremendous amount of time in your setups. And that's the name of the game these days. Flexibility seems to be another big thing. You know, I don't personally have a lot of users that are doing part runs that are in like the 500,000 range kind of a thing, where the setup just runs and runs and runs. They're running 500 parts and they're on to the next thing. So having this ability here to not have to futz around with all those fittings and lines and worrying about whether the coolant's actually being efficient or not is a huge advantage to them.
Right. I also noticed you brought your own coolant through gang here. Is that for, we come with one now, but is that for like older machines?
So this is, yeah, exactly. I'm glad you brought it up. So the L320 comes like right out of the box with this, if I'm correct. That's a standard option, but there's a lot of legacy equipment out there, and that legacy equipment is highly effective still. And one of the things that we do at GenSwiss is we try to make it so that people can keep legacy equipment effective and productive longer. So what we've done is we've actually built our own GTF blocks that incorporate the coolant delivery through the plate again. But instead of delivering through the tooling itself, like these are showing over here, we're actually delivering it through the clamping wedge. So the clamping wedge has the coolant jets integrated into it, and then you've got a whole range of switching valves here. So sometimes a user may not be so keen on running the high pressure coolant on their threading tool. Maybe that can just be fine with the flood. But of course you want high pressure, and you're going to want it full force on your cutoff. It's the hardest working tool in the machine. So you could redirect the coolant that way. You could use two different inlets from the cool blaster and control them with your control. So you've got 3 channels that are fed off of one line and 2 that are off of another. And these are actually also configurable in different manners too. There's some that have 1 circuit or 2 circuits, or even up to 3 circuits, depending on the machine application. But the one in my hand here would be compatible with an older L20, like an L2. Nice. So anybody who's got that equipment and they've been running it for the last 5-10 years or so, they could make that decision to retrofit that right onto their machine and then eliminate all the brake line bending and all that. So
I also like the little stops I'm seeing on here for repeatability and setting up the tool. Like the little set screw clamps it down, and then you just set right back against that block, right?
Yeah, so it effectively turns your entire tool crib of square shank tooling into quick change as well. So you're not messing around with the high pressure lines anymore, and you can set all your stops so that any square shank tool that's a high quality square shank tool with a repeatable overall length, you could get really close after a tool change pushing it up against those wedge stops.
Nice.
So a lot of thought and engineering went into this, and one of the things that I always like to really highlight is you're not pigeonholed into one brand of tooling with this. So you install this on your machine, you could utilize any square shank tools with this. So I understand, I would love it if everybody ran Utilities multi-deck. That would make my life so much easier, but we can't be everything to everybody. So, and one of the things that we're talking about here is flexibility and capability, and nailing somebody into one brand of tooling because they put a specific plate on their machine is something that we want to avoid, because that's going to keep them competitive that way.
Right.
Plus, they've already got the investment in a lot of their square shank tools, and so everything that's already on the shelf in their tool crib could potentially be utilized with the coolant through capability of the tool wedge.
For sure.
Real quick, I'd like to talk about some of the insert geometry too that we've got on some of those videos that we had done a little while ago there, the G line.
There is a question online I'd like to chime in for your previous.
Oh, sure, yeah.
Sure. Someone, Riemann responded, I like holder, my preference is always hard to plumb. So if you don't want to comment on that.
That's, like I said, that's some, from my experience, we're seeing that from a lot of users just saying how much time they struggle. And there's a lot of times I'll get phone calls, because we do a lot with the plumbing and the lines as well, and people will call me up asking for a very specific fitting that maybe doesn't exist. So adapting over to what the L320 is doing, or retrofitting an older L20 with the multi-deck lube plate, eliminates all that headache. You're not looking around on Grainger looking for a fitting that doesn't exist. To get to, because everybody uses a different fitting for their tool holders, and it's always a challenge. So this sort of thing makes it easy. And then you're also saving money just on the tool holders, because the tool holders themselves are inexpensive, because you're using just your regular square shanks instead of any that have coolant through ports on them.
Yeah, unfortunately, not every manufacturer has made tooling that interfaces with this, but GenSwiss has been one of the earliest adapters of that, and I appreciate that about it. And because it's a slot on the gang slide as opposed to just a port, you have a little bit of space that you can adjust your tool up and down and still deliver coolant through that tool.
So we call it out real quick. You can see right here on the tool holder, there's removable plugs. And depending on how do you want to utilize the tool holder itself, there's no shortage of how you're going to be cutting this thing into it. So the big plug right there would actually be the one for the coolant through plate that's included on the L320. But you've also got connectivity through fittings and lines and everything like that also incorporated into it. So very versatile tooling right out of the box.
Absolutely, and honestly, I like the nomenclature of a lot of it too. It's a lot easier to follow than a lot of the other competitors. I just pick up the shank and I can read exactly what it's for, exactly what inserts I need for it, like right on the tool, as opposed to needing to decipher some hieroglyphics or some dead language.
That right there was one of my favorite things about it, because so we've been working with our partners Utilities now for almost 20 years, and when they first came on board, I was extremely intimidated by the nomenclature, trying to figure out how am I going to get what I need, how much time am I going to spend picking tools. And the thing that I like to really point out to everybody again, so going back before talking about this 3000 series tool system, it's a one holder system. So if you see in the part number that it starts with a 30, you know that it's compatible with that pocket. And then after that, the rest of it just breaks down into dimensional data. So the 02 just means it's a cutoff. Our 03 would mean it's a front turn. 04 means it's a back turn, 05 means it's a groover, and so on and so forth. But as you go down the nomenclature, the 2.0 means it's a 2 millimeter wide cut. The 10 millimeter means that it's a 10 millimeter depth of cut. So this is a cutoff tool that we've got as an example on the screen right now that would be perfect for the L20, because your max depth of cut's 10 millimeters. You're parting off a max 20 millimeter diameter bar. Then we get into the handedness. So you just look right at it, right-handed. The SC would designate whether it's a plain type or a chip breaker type. And then lastly is our carbide grade. And our carbide grade on the cut series tools is really simple. We have one grade, UHM20, which is a very nice balance of hardness and toughness. And then lastly, we get into coatings, and we've got two coatings available as standard. HPX, which is a traditional Thailand, and in the video that we just watched, most of those tools were TX Plus, which is our optimal product for stainless steels, titaniums, and previously we actually used to offer it as special order only for aerospace alloys, but now we're offering it as a standard product on virtually everything. We're finding it cuts and just about any kind of material that you might want to be running on your Swiss lathe. So it's it's an optimal product. The other thing that I kind of want to go into a little bit is some of the geometry that was shown in the video there. We have a new series of tools called the G-Line, and this is using a new manufacturing technology over in Switzerland that is to put unique chip breaker control onto carbide that was previously too difficult to do. So like these are really small tools. Trying to do a complex chip breaker geometry like this with a grinding wheel was impossible. So we've got this new technology over in Switzerland for manufacturing this chip breaker. And so the groovers that we used in our demonstration here was this actual one that's on the screen right now. We call it the GC20, and it's an omnidirectional tool. You can plunge with it, you could face with it, you could back turn with it. Every side is relieved for doing cutting. So it's kind of a jack of all trades kind of a tool, and it's got that chip control that's built in specifically for the kinds of materials, again, that we're going to be encountering when we're running a Citizen L20 or any Swiss machine.
Yeah, I definitely used every side of that insert in that demo.
And then the other one is, so we're talking about the OD turning initially on that demo part, and we used a tried and true DCGT just for the simplicity of it. But we've also got the capability of using what we call our 3003 front turn GA20 tool, and this is one that GenSwiss is actually really proud to say that we've put an L32 on our own shop floor in the recent times here, and it's LFV equipped. And we've done a few test cuts with this particular geometry, and we find that it actually performs very admirably. Maybe actually you might want to explain a little bit about what LFV is.
LFV is our programmable chip breaking technology, low frequency vibration. So what it is you basically program an interrupted cut into your turning, and a lot of our competitors have something like it, but the big difference is ours is always vibrating along the direction of the feed, whereas theirs only vibrates in one direction. So if we're making this taper on the back and we're using LFV, it's actually turning at this, it's vibrating along this 15-degree angle as it comes up the taper, whereas a lot of our competitors that claim to have something similar, you'll look at it under a microscope, or honestly, sometimes you don't even need the microscope, and you just see these steps in the taper as the vibration just digs these little steps into the taper instead of giving you a nice smooth finish like the LFV does with 2 axis. And very, very new is the ability to increase the number of axes you can use simultaneously. Because on the 70 control, the L20 that you had, you could max 2 at a time. So you could do Z on $1, Z on $2, or X and Z on $1 and nothing on $2. But in the 800 control, you could do up to 3, but now 70 control, 800 control, as long as your software is updated to sufficient macros, you have the ability to do 4 axes at a time. So you could do, a taper on the back and a taper on the front, and you can just do that where normally you couldn't. You had to choose one or the other where you wanted your LFV at that time, or you had to balance your whole process around when and where you wanted LFV to account for the fact that you had a limited number of axes. And that's out the window now. You can pretty much freely use it at this point, and it's really exciting, even though it's still new to us. I think that's not even a month old, that software.
Oh, that's excellent. And the LFV is a seeing is believing kind of thing. Because like I said, I've been doing this for quite some time, and it's always been about high pressure and chip control on the tools themselves. But when you see that machine breaking those chips and still generating a really nice finish, and something that might normally be a real big headache, where you're going to have a whole wrap of chip just kind of getting up and all over everything, and now all of a sudden you don't have to worry about it. The name of the game is keeping that door closed longer, making more parts, rather than going in there with needle nose pliers and cleaning your tools off and being worried about breaking things. So the LFV really is a game changer when you're getting into materials like that.
Yeah, for sure, a lot fewer op stops in the program for exactly that situation. I like to say that in the right material with the right LFV profile, it's the difference between your chips being a bowl of rice and a bowl of noodles. It's just,
I like that analogy. It's really good.
You could, I don't know, I wish I brought a picture of it, but you could literally see the difference. And it's programmable chip breaking, and it sounds a lot more complex than it is. A lot of times people will say, "Oh, Vince, can you come out to our facility and teach us a class on LFV?" And then I go out there and I'm done in half an hour, and they're like, "That's it?" Yeah, it really is as simple as we say.
The programming of it, isn't it just really just on or off? Isn't that the basics of it?
You say on G165 on, and then you give it some details about the exact parameters of your vibration, and those are going to need to be tuned to your specific geometry, your specific tooling, your specific cut, but your material, obviously. But once you dial that in, it's like I said, difference between a bowl of rice and a bowl of noodles.
Definitely a game changer for sure. So with that, I think we kind of covered the front turning side of the job here. So we've worked our way up from the thread at the beginning up to the part off part of it. So I'll kind of go over to what we did on the subspindle side now. I think is probably the next direction to go with this. So on the subspindle side of the machine, we utilized what we call our multi-deck back turn system. And the multi-deck back turn system is what I usually recommend for any machine, regardless of whether they have a Y-axis on the back or not. This gets you away from having to use an ID boring bar for OD turning, because a lot of people are still doing that. They'll use like a CC insert or a DC insert that would normally be meant on a bigger machine for ID work, and that's not really the way to do things on a Swiss. So this problem solver that came out from Utilities many years ago makes it very easy for doing work on your sub spindle. So what we've got here basically is a tool shank that would go into one of your ID working positions, and it adapts out into an OD type of module. And the other added benefit is, so the L20 that we're working on today has Y-axis on the backside, so you don't necessarily need this, but there's a lot of machines out there with only X on the backside. And what you can do with this, and see if I can get it up here where you can see, we've got adjustability built into these guys. So if you're doing a turn and you're struggling to reach the center line, like facing off your part on the back to remove like a cutoff nib or something like that, and you're struggling to reach it, now you've got the ability to adjust that tiny little bit out on your OD turning tool. Now, as Vince mentioned earlier, when we were showing the on-machine demo, we were using the same tools on the backside as we were using on the front side. And I set it up that way on purpose because that's kind of a thing that I really like about this system. You could use virtually any kind of tool on this module back here. We have a whole array of them, but for today's demonstration, I wanted to show that you could use the exact same threader that we used to do the front thread to do the back thread as well on the sub spindle. So it limits how much tooling you have to purchase in order to complete the workpiece. And then it also gives you a flexibility down the road, because you might be able to, as I said, 3000 series is a one-pocket system. You could change that geometry and put a groover into that. And in fact, we did do a grooving operation in our demonstration here. So you can just change out the geometry and do all kinds of different operations from this. So it's a great system for working on an advanced machine like the L3, but if you've got an older machine, I still see customers out there with L520s, and that one's near and dear to my heart because that's one of the ones that I first really grasped the tooling layout of. So seeing the people still running L5s, which is right around when I came on board with GenSwiss, is awesome, and I can go to them with this tool and go, hey, you guys really, you need to be doing this on your sub spindle instead. So and there's like I said, there's a whole array of different operations you can do with that. If we can pull that up now, yeah, here we go. So we were using the Cut 3000 for our demo, but we've got VCGTs, we could do DCGTs, we could do all the standard ISOs. We've got a boring bar adapter, we've got a round shank adapter, so you can kind of utilize your own solution if you need to. And this gives you the benefit of a nice rigid setup on the sub spindle. The material that these holders are made out of, I mean, these are really dense. I'm not sure what kind of tool steel they are, but they're vibration damping. So it's a very rigid system. Very good way for doing any kind of work on the backside of your CITIZEN machine. It's comprised of 3 different modules. So essentially you just establish it with the shank that fits your machine. We've got spacers in case you got to bring them out because your adjacent tools need a little bit more clearance. And then that last module goes on the end. We do have coolant adaptability where you can bolt on an added flood line that can feed from the cool blaster. And there's a lot of different ways that you can configure this thing. We've got inboard facing orientation where you've got your tool nose at your center line of your tool position. And like we did with the Cut 3000, it's actually facing outboard. So under certain scenarios, you might need a little bit more stroke, a little bit more Z2 stroke. Right. You've got some additional clearance that way. So this is something that I always try to really focus on when someone's struggling doing sub-spindle turning. This solves a lot of problems in many cases where you got a tool that's more adapted for that kind of work. Mm. So I think that kind of really covers a lot what we wanted to go over with the tooling. Oh, yeah, we almost forgot my favorite one. We got the tie lock. We got the tie lock here still. On the final operation that we did on the sub spindle on our demo here was from a live tool. What is that? A GSC 1507? Is that what that live tool was that's installed in the sub?
I believe that is the cross-working one.
Yeah, the cross-working one. So you were able to see how much distance there was, and that was a small end mill, maybe a 4mm shank or something like that, and how much distance it needed to get to the workpiece. So utilizing the end mill extensions that we've been offering for the last several years really shores up some of that distance and gives you better stability while in the cut. So a good example of that is, on your gang slide, you might be running a 3/8 end mill adjacent to like an 1/8 inch end mill. You got to bring them all out so that you have your clearance. They're able to reach the workpiece adequately. But the traditional way of doing it, you would have low rigidity. Right. And that sticking out a tool that far would also affect your TIR, and bad TIR affects tool life, and so on and so forth. So doing micro end mills on your Citizen lathes now is so much easier with tie locks for shoring up some of that distance. So you can see how much is done by our stainless steel extension there, and it's really just your flutes at that point that are still protruding. And you get the side effect benefit of it being also quick change. As Vince said before, he's broken some end mills off in these things, and you just simply loosen those locking screws, change out that end mill, push it all the way back up. There's an internal stop in the back that you can adjust, and you're up and running again. You don't have to break the tie lock free from your live tool in the machine. So it's another one of those things that just saves you time and gets you back up and running quicker.
Yeah, I started using those a couple IMTSs ago, and they have absolutely saved me a number of times. I cannot sing the praises of the tie locks enough.
I love hearing that. But my personal anecdote with them is one of the very first customers that bought them. They were kind of skeptical, and he bought one. He bought one to try out. Calls back a week later and goes, I gotta buy a dozen more. He's like, my guys were fighting over who got to use it in their setup. So that was when I knew we had something going on with that product. So it's definitely one of my favorites. That's a GenSwiss signature product. It's something that we came out with a little over 10 years ago at this point. I think we're pushing maybe almost about 15 years since we introduced it. So it's definitely a nice problem solver to have available in your tool crib.
Oh yeah, if I break a tool at the show and I could change it before anybody notices, that's a great show for me.
I love it. So I think that kind of covers everything I wanted to go over with tools. I think we'll probably move on to talking a little bit about the control, right?
Yeah, a little bit. Before we do that, we touched on during the demo how simple it is to program some of the operations. So if we could call up the B-axis snippet, I'd like to show exactly how simple it is when I say, guys, it's really as simple as I say it is. So, just real quick, that M346 is the interface with the ATC. It's a 12 station carousel of live tooling, live B-axis tooling, and plus T11 above it. So with the ATC, you have 13 front-facing B-axis tools, and that first line just says, hey, go grab it from this pocket in the carousel. Then after that, I just call it as T12 exactly like I normally would in any other context. Install my offset. And then that G930 move, that's the entire B-axis. I just give it the center of my hole and the angle of the rotation, and the machine basically wraps the coordinate system to that 45-degree angle, and now Z is my tool. So that next line, G0x0 Z minus quarter inch, anyone who's ever drilled a face hole, that looks very familiar to.
They can do it.
Yeah, absolutely. So I establish my zero, I establish my clearance, I, bring it in, and then that G83, that's it. Like, that's the entire thing. That does all 6 holes on the B-axis because I use the K and H arguments to index it around. And I can even just copy-paste this and change my PEC argument to be the entire full depth of my spot, and I can even use the same code, the same center, the same coordinate system, and B-axis programming has never been easier. It really is as simple as I say. You just program it like a normal face-op, and as long as you're in the right mode, G930, the machine takes care of the rest. The 800 control is also our first true 5-axis B-axis offering. Previously it had been 4+1, so you have, X, Y, Z, C, B. You could pick any 4 of those on one line. Now that's a thing of the past with the 800 control, full 5-axis all day.
I love the simplicity of that, because the first time I saw the B-axis doing work and doing angle drilling holes, it just looks like, I can't imagine what the program looks like to take care of that. And you and I were going over this yesterday, talking a little bit more in depth about it, and it was like, wow, it really is that simple to do complex features. So like I was saying before, thinking back to the first machine that I really started to understand, being the L520, this part would have been kind of tough to do on that, to program an angled hole with the old controller. But the new control makes it so much easier, especially with the tooling capability tied to it. So it goes hand in hand, having the tooling capability, but also the control that kind of conducts the whole the whole recipe for success, really.
For sure. Yeah, and all the numbers on there are literally just straight from the print. You know, that's the center of the hole. That's the depth of the drill. You know, that's, you just program the print and the machine takes care of the rest, as I say.
Yep.
Yeah, speaking of which, let's take a look at that control. The 800 control has a lot of new features that I personally love. The first one of them is the home screen. People who are more familiar with the older versions of the Mitsubishi control may remember all the soft keys, which still exist, but you're sitting there hitting menu select, looking for which parameter page you were just on. Come on, I was just there. Why can't I find it again? Oh, there it was, but I missed it. I have to menu select all the way back around again. No more. The home screen is every screen on your machine that is relevant in one place, one easy to find place. It's the most intuitive control I've ever touched. Everything is pretty much right where I expect it to be and right at my fingertips anytime I need it.
I'm a very visual person, so like seeing how that stuff is laid out for me is a great way to learn.
I mean, you're in for a treat then, because this is a very visual control. Right now, the touchscreen is being demonstrated. It is a touchscreen, which is, you know, as long as your hands are clean, it's works perfectly fine. But one thing that you can do is it's easier to make, say, multiple program selections like this and just input them in one shot, as opposed to having to, you know, type in the number, send one, type in the number, send the next one, and doing it one at a time. Nope, just click every one you need, send it over, you're done. But otherwise, it's the same I/O screen everyone's already used to. The edit screen, again, anyone familiar with the old controls is going to see a lot of familiar stuff here, just in a new package. But one thing that a lot of people don't necessarily utilize to the full extent that they should is MC data. This is some programmable information from Citizen's platform that goes with the machine. And as you said, you're a very visual person. Well, this tells you what every field is going to be. You know, okay, that's positioning point. What is that? Well, that's the clearance that the tool makes when it indexes, and it shows you right there on the screen. And this is all stuff that is addressable, so your program can go and take, you know, a 5/8 bar stock OD, and that's how it knows where to index. But you can call it in your program. So just off the top of my head, the variable for bar stock OD plus positioning point is 100 450 plus 100 451 on the 800 control. So if I program my tool index with that short macro combining these two digits, oh no, you know, we're at a 5/8 bar, but you know what? I can make this part out of 3/4. I just changed that number from 5/8 to 0.75, and you know, the machine takes care of the rest. I don't need to go in and retouch off my whole setup. I don't need to go in and adjust anything else. I just need to change my collet and guide bushing out to accept the new bar stock, and I don't have to touch my program at all.
And there you go. There's a whole nother thing about just making life on the shop floor that much easier.
Right, a little bit farther down, you're going to see the back spindle stick out length. Same thing. You can program your pick off around it. So okay, well, I actually need to choke up on that, or, you know, bring my part out a little. Well, if you utilize that in your programming, then you can do that on the fly in MC data, and you don't have to change your pick off position. You don't need to retouch off your back working tools. Like, all of that is taken care of. And this is information that when you output your program, this comes with your program. So you go to set that up on your other L320, and all the same information is there from the previous job, and it goes from machine to machine, it goes from, you know, job to job, and it's constantly there embedded in your program.
Stepping back a little bit there too, you said there's a whole library of your tools in there. So like your common like GSC 1310 that fits all the gang slide positions and backwards positions like the L32, that kind of stuff. That's all integrated into that.
Right, and we'll get to that on page 2 and page 3, or holder info 1 and 2 pages. But right now, Logan and his giant ring were showing us the guide bushing feature. So all of our machines can switch from guide bushing list to guide bushing mode. Well, actually the reverse, because they come standard as Swiss. But you can remove the guide bushing and program it in what we call guide bushing list, non-guide bushing, chucker mode. It goes by many names. But ultimately, you can make it a conventional chucker if you need to for whatever reason, because a guide bushing will only clean up about 40% of the error of whatever you put in there, which for brass can be pretty bad, especially if you're not run ground stock. But so you can clean that up and use, you know, worse material going in chucker mode because that'll turn it straight, but then you're back to roughing, finishing, and all conventional lathe stuff.
But again, we're going back and talking about what we were saying earlier in the program, a whole lot of flexibility. You never know what's going to come through the door these days for a job, and now you got a piece of equipment that can handle a whole lot more.
Absolutely. I've absolutely run jobs that worked better in chucker mode for, various reasons. Yeah, continuing on, the holder info. So Scott was just mentioning this about the holders. Our entire tooling library that we make, Citizen manufactures, is in here in the MC data as well. So you pick what is loaded in your program, what your machine needs to process this part. It shows you a picture right there of what it is, shows you what each tool pocket is, and you just pick it. So your operator doesn't need to know what all this nomenclature necessarily means. He just needs to see, well, is that what's on my gang right now? Is that what's loaded in my back working stations? Because, if it is, then I'm all set up. And if it's not, well, I better change that holder.
Yeah, I definitely have noticed that machinists are generally very visual learners, and having that integrated in there is a game changer, because I'll oftentimes get people calling in with a machining strategy that they're trying to accomplish on their machine, and talking about the different live tools that they've got, and I'm trying to ask them a little bit more questions like, well, what do you have in your hand right now? What is the thing that you're working with? And having it all as a library in the machine just it makes it so much easier. It makes it so much easier. And the control even calling out which position that they've got it in, because then I can go, well, where are we working from? The T20s? Are we working from the gang slide? Are we on the sub? Where are we? And it's all clear as day. So we're all on the same page when we're trying to develop a strategy for whatever it is they're working on.
Right, and like you said, it is easier, and it's safer because the collision zones for all of those holders are built into the machine as well. So it knows the moment it's going to get within a millimeter of itself, essentially. So as long as your safeties are on, we say that Citizen Steel will never hit Citizen Steel unless you disengage the collision zones for whatever reason.
So again, avoiding those expensive sounds.
Yeah, exactly.
Making it easier to be successful, making it easier to be productive.
Right. So this is the MC structure screen. That's, you're not going to spend a lot of time there, but it does give you control over the options that are loaded in your machine. First two pages are absolutely free to change whatever you need. You could change it from inch to metric, sub-inch on and off for whatever you need to do that for, various things. Sometimes you actually do need to turn it off. And then everything on 3, 4, and 5 are just paid options, increased memory, eccentric turning, things like that you might get an upgrade, but you're probably not going to spend a lot of time here. But if we need to know if you have something available, this is where you would find it. So the prep page, we were just looking at the MC data and making tooling selections from that. As you see, it does call out which tool pocket is which on each block, and this entire page modifies with your MC data. So whatever you have in your MC data, this page is going to hide the stuff you don't have. It's going to show you the stuff you do, and it's going to show you pictures of exactly what it expects to be in the machine. So there's our ATC head right there when he was looking at T12. There's our back working block. In the 20, or our front working block in the 20 stations, and then T31 is going to be our back working block. And again, it shows you right there in the image where all your tool pockets are, so your operator doesn't have to have the entire tool layout memorized. It just shows him right on the screen.
And see, and again, from my standpoint, when I'm on the phone with somebody trying to help them solve a tooling problem, what position are you trying to run from? They could look right on the control screen, and there it is. That helps me tremendously. In the machine, they're all marked with like etchings and things, but as the machines age, it gets harder and harder to see them. There's chips, there's oil. Looking right on the control, seeing exactly what tool position you're at, it helps me out tremendously. So I love that about it.
Yeah, absolutely. And sometimes it's just not in a place you can see.
Yeah, exactly.
It's just clamped on it.
There might be, stuff in the way. Yeah. Tooling and everything else. So.
Oh, it's on the back of the spindle. Yeah, things like that. The edit screen's a lot more intuitive thanks to the touch screen. A lot of people don't know about the code list, but they should. This is every G&M code in your machine, and this is accessible from every place that you can edit code. It's on MDI, it's on your edit screen, anywhere you can edit code. And you can scroll through it, get any M&G code on the machine, and it shows you in the right side panel what all the arguments for it are, what they do, and then you can go and pull up this little form that you can fill out your tool arguments, put whatever data you want for the cut you're trying to achieve. In this case, he's filling in some stuff for G76, and then if you hit that code insert button in the lower right side of the window that popped up, that just dumps that right in your program wherever the cursor was when you entered this screen, and then just dumps it right in your program. So if you don't remember, again, you don't need to memorize the entire G-code library. It's right there on your machine, and it'll remind you exactly what it's there to do, and all you need to do is fill it out if you need to make a program edit on the fly.
Great from a training standpoint too, I'd imagine too, because you're going to have somebody be able to probably help themselves instead of going to a higher up to ask a question or something like that. The machine's going to help them work it out.
Absolutely. We got a new guy on our L12 that's literally writing a program from the code list because that's just what he's doing. That's what he wanted to do, and good for him. Look at him go.
That's awesome.
Practically training the kid for us. So the menu list is good too. Like that's a little thing, but you open it up and you can get all your soft keys. But he used it to pull up the feeder operation screen, which brings up an excellent point about the CAV. The CAV is our bar loader with an integrated A7 axis. So that is always going to be following. It's not just a pusher. It's always going to be following your main spindle as long as the collet is closed, and you can operate it from the control instead of having to walk 12 feet down the machine and do everything from the pendant of the bar loader. You don't have to. Also, again, it pulls data from the program from the MC data. You see that auto setting button in the upper right hand corner of the window? You change a new job in, you press auto setting, it reads the MC data, and it adjusts the bar feed parameters based on the program that you've loaded, the length of the part you're trying to cut, things of that nature. And you don't have to then change the program in the machine, then, oh, did I remember to change the program in the bar loader? Oh, is the right program loaded into the bar loader? Like, no, it's fully integrated into the control on the machine, everything operated from one place. Let's see what we got here. Oh, he's showing the operation levels now. The guys who signed the checks love this one.
So you got the authentication, right?
Yeah, absolutely. You can make your operators log in and control all sorts of things that they are allowed to have access to. Who can edit the program? Who can edit the parameters? Who can turn the coolant on with the door open? These are things you don't necessarily trust everybody at your shop with the power to do. And so you can limit that by deciding who gets to do what. And as long as you're logging out of your account and someone else has to log in, then you can limit what they're able to do on the machine and the amount of damage they can cause to the program you spent weeks proving out.
Or avoiding expensive sounds.
Or avoiding expensive sounds. This looks like the high-speed check function. So the high-speed check is great. It lets you go and basically cycle through the program without moving any axes on the machine. It also fully simulates the position data. So even though no axes are moving, the machine's position data screen is gonna change as if it is moving, and then it'll give you a rough cycle time at the end. But this means that if for whatever reason it does stop the program, you over-traveled Z2, you have a collision zone in this drill, whatever, you can go and you can see, well, how much distance to go did it have? And it helps you prove out your program with some data that you didn't necessarily have available to you either on other controls or on previous generations of this control, because it's fully simulating the program operation even if it doesn't do that by moving axes. That and handle mode are two really good ways to prove out a program, because that little jog handle under the NC to the right of the E-stop, you can literally handle through the program forwards, backwards to some degree, and so you can fully control your prove out process between the distance to go of the high-speed check simulation and the the same data, but actually moving it slowly through the program process using the jog mode.
Yeah, everything we can do to make sure that everything's proven out before we hit that cycle start.
Yeah, absolutely. And yeah, I guess he's showing the manual operation screen. But again, like, it shows you what plus and minus is. You'll notice as he changes the axes, it shows you exactly what axis that is in the layout, and it shows you what direction is plus, what direction is minus. He could change the speeds he's jogging at, 1, 10, 100, 1,000. You know. So again, like you said, very visual control, very intuitive experience.
I could see a new operator with minimal training being able to pick that up and really start to be able to navigate their way through it and become more effective quite quickly,
Right.
once they hit the shop floor.
Now, one thing it doesn't look like we got footage of, but I love about the 800 control, is that if you go to the offset screen, it shows you in a column on the right-hand side exactly what tool is calling up that offset. So again, your operator just goes to that screen and can see which tool is calling up that offset in the program that's currently loaded, so he's always changing the right offset when he needs to change a specific operation.
Excellent. Excellent. That pretty much ran us through the content there, right? We got everything we got?
Yeah,
Yeah.
I think so.
Awesome. Awesome.
That's everything
So
I had planned.
we did hit just about an hour. I think at this point here, we'll see if we can take some questions. If we got a live studio audience here as well, so anybody here wants to ask some questions, feel free to speak up. But we'll also go to the chat and see if we got some questions on there we can answer.
Yeah, this is the audience participation part of the whole thing, so.
So let's start with people in the room, and we'll actually reloop the video from the beginning of just the whole process and the parts so we can take a look where we're at.
Yeah, fair. That sounds good.
What's the advantage of the ATC compared to just the straight four gang tool?
Well, I mean, it's the advantage is the increased amount of the B-axis tools you have available to you on the front. That comes with the trade-off of the B-axis tools in the back. So it's not exactly the silver bullet for everything, but for the right process where you need that many more live tools on the front and you need that much more angled work on the front, it's a worthy trade-off because you're going from 4 B-axis tools in the front to 13, and you're going from 4 B-axis tools in the back to 0. So you net a lot more tools than you lose, but it is a trade-off, and it's not necessarily for every application, but for the ones that it can shine on, it really does shine. The ATC carousel is even fully integrated with the tool life system, so you can have that redundancy of having the spare tools loaded. You know, so if you have micro mills that you only get X amount of parts out of, you could set it up so okay, pocket 1 is the tool, and pocket 2 is the spare tool, and so you can always just run lights out to some degree and have extra tools for the operations that are coming off your ATC carousel, where that just straight up isn't an option when you have the normal B-axis holder.
That's a great application solution. That's one that I hadn't even really thought of until you just said that. That's a great use for that, because then you can run longer or potentially even lights out at that point if you've got you got that capability. So
Yeah.
Do we have any more
Anyone
questions
else?
inside
Yeah.
here?
Crickets. Chat then?
We'll go to the chat. So there was a question before about LFV. If you can go a little more into capabilities of LFV, what tooling for what modes, and if you can have that conversation.
Generally speaking, you want a little bit more of a wider nose than you normally would.
Just repeat that.
Yeah, repeat the question.
Oh, sorry. I thought.
no
Yeah. So the question was something about LFV, how they wanted to go on a little bit of detail about tooling choice, it seemed in particular, but to a lesser extent, just general concerns. Generally speaking, with turning, you're going to want a wider nose than you normally would. Like anything dead sharp is probably not gonna get the life out of it, because essentially at the end of the day it's a controlled interrupted cut, so you need something that's going to be rigid and stand up to that. It's also whatever feed rate you program it at, it's physically moving faster than that because it's essentially simulating the programmed feed rate, right?
Yep.
But it has to step back, so let's say
Air cuts for a few degrees or so.
something like that. Just to nutshell version it has to step back to vibrate forward. So you program 1,000, or 1 thou per rev, and it's going to move forward at 1,000 per rev, but to do that while it's moving backwards, it actually has to move faster than that. So you need inserts that are going to be able to hold up to that kind of punishment, and it will. Like, honestly, if you have sane LFV parameters, it's not going to drastically affect the life of your tool. If it is affecting the life of your tool, you probably need to dial back the intensity of your vibration.
And that's where, going back when we were talking about the tooling at the beginning of the program, that GA20 3000 series front turn, that's one that we threw at the LFV on the GenSwiss L32 and found that it performed admirably. So that's kind of becoming one of our go-tos whenever a customer has an application where they intend to run the LFV, because you've got a little bit of an edge break, they've got a slightly honed edge prep on them, and they are available in bigger radii. Like you said, you want a little bit bigger radius for the strength. So.
Yep. Yeah, you want that, and you want a good, like, sharp chip breaker. You generally don't want those less sharp kind of like cup version, I'll say. You want something a little bit sharper as far as your chip breaker goes.
Kind of
but
angular
not as
almost.
Yes,
Yeah,
exactly,
it's gonna
exactly.
Instead of a scoop, it's going to be kind of like a chisel.
Yeah, pretty much. And like I said, you also want to avoid. Well, it's a lot of it's also material dependent too. So you may change. That's all general stuff, but some things may change based on what material you're running, exactly your geometry. Like I said, there isn't a silver bullet. Well, if you do this, it'll work 100% of the time. You do have to kind of tune it in.
There's good
to
ways.
your specific job.
I say to our customers all the time, there's good ways to do things, there's better ways to do things. And if it works, then it's not the wrong way.
Right. Yeah, there's a lot of that in LFV where it'll work, it won't be wrong, but could it be better? Yeah, and you have to tune for that.
That comes with experience.
Yeah, it does a little bit, but there's some good documentation on it too, where it's just like if you're seeing your chip that do this. If your chip is too long, adjust this parameter until it breaks. If your chip is too short, which can happen because if you're making powder, that's just going to end up in your coolant pump. So maybe you want a longer chip. So, again, you just program your vibration intensity to get the chip you're looking for as opposed to the chip that the machine wants to give you.
Gotcha.
That kind of goes into the next question. Can you discuss a little bit more about LFV parameters, and you're kind of just discussing that currently, right?
Yeah, we could talk a little bit about LFV parameters. Basically, the parameters are going to vary based on what mode you're in. If you're in mode 1, that's going to be the amount of vibrations that it's going to make per revolution. So, you could get up to, I think it's 6.5 vibrations per rev and up to 2.5 times your programmed feed rate for the amplitude of that vibration, the intensity of that vibration. And so for mode 1, you have your Q and D arguments that control that, and that's going to be what you're going to be adjusting to get your chip size. Then in mode 2, you have it's the amount of revolutions per vibration. So that's more for like, I've got a tiny drill, I've got some ID work that I need to do, and I'm trying to, I need to, maybe just a tiny OD, and something that requires a much higher spindle speed that I'm not going to vibrate. Like, at 6,000 RPMs, you're not vibrating 6 times per revolution. That's not happening without damaging your machine. You can program LFV in ways that you'll run it, and it'll make a noise that sounds a lot more expensive than it is, but it definitely is a sign that you should tone it down a bit if your machine sounds like it's breaking itself. So mode 2 is for higher spindle speeds, which is usually going to be ID work. And then for that, you have the E and the R arguments that basically do the same thing as the arguments for mode 1 does. It's the number of revolutions before it vibrates once, and it's the amplitude based on how far back it's going to vibrate when it does. Except in mode 2, it's based on, I think it's half a revolution. It is the default, and then it goes up. And then mode 3 is special for threading. Now that's the only one that doesn't vibrate along the direction of the infeed. That's going to vibrate perpendicular to it, because obviously if I have a thread and I'm vibrating in Z, that's going to completely ruin my pitch. So we actually vibrate in X as we're going on a Z thread like that. And mode 3 is a little special because it takes all 4 of the arguments that we just spoke about, but only 2 at a time. So you can basically program mode 3 for threading as if it is revolutions per vibration or vibrations per revolution. Generally speaking, you're probably going to use mode 1 for it. We generally, you don't single point thread at significant spindle speeds. So, you know, obviously everything is going to have its own exception, but generally speaking, you're going to use the mode 1 parameters for mode 3.
I'm going to say thank you to whoever asked that question because I learned a lot just from that. I've had a little bit of time to play around with the LFV on our machine, but not to that level of detail. So I definitely learned some things right there.
That's fine. One big thing about LFV that a lot of people, I think it confuses a lot of people that are new to it, is that the manual shows a whole bunch of tables that a lot of people look at and they say, oh, so these are starting points for what my argument should be. No, those are clamps. So what it's basically saying is if you give it these parameters, then this is the limitation that the spindle will have. So a lot of times when people have trouble with LFV and they call me and they ask about it, the problem tends to be that they're running up into that spindle clamp and the spindle just isn't rotating as fast as they programmed it to because they chose vibration parameters that clamp the spindle at a lot of lower speed than they were expecting to actually get.
Excellent. We have any more questions, Rob?
We could open up to the audience before I go back to the chat. If there's any questions that people thought of or anything relating to the print that you would like to discuss and how we looked at it and maybe that jog some questions in the audience.
Yeah, maybe something from the machine we didn't touch on or something that's not about LFV.
Something maybe I forgot to even pass and touch on. You know, sometimes I get excited about things and kind of forget a key point.
We'll let the audience stimmer a little bit, but there is another question that maybe relates to how you process a part. So there is a question about Swiss lube and what to use when using certain materials or certain tooling. We can start a discussion maybe on that and how it relates to what kind of coolant that you use or would recommend.
Coolant. Well, I mean, honestly, at the end of the day, I go to a lot of shops, and every shop uses a different coolant. Everyone has their favorites. Primarily, I would just say
oil. First of
all,
all,
oil. Yeah.
100%. It's oil.
That's my big one. Like I've done a couple jobs in water-based, usually for our laser tooling. I prefer oil, but the problem is once you got the laser, you can only really use oil
water
once.
Soluble there. Once. I could speak to the oil thing a little bit. So GenSwiss actually has a line of Swiss lubes. It's called Swiss Silver, and there's a whole array of different formulas depending on what you're doing. The big one, we're talking about all the high pressure that we've got going on right here. My number one question for a new user who wants to talk about Swiss lubes is, do you have a cool blaster installed? If they say yes, we have a high pressure formula, and the high pressure formula is paramount when you're running the high pressure pumps because it does put a lot of air into the cabinet, and you want that to kind of float its way back out when it reaches the sump quickly, so you don't cavitate your pump, you don't have too much misting and all that. So it keeps everything running a whole lot smoother. So that's probably my number one recommendation when looking at Swiss lubes is if you're running high pressure, find something that specifically states that it's going to be for high pressure coolant delivery, just so that you don't have any of those issues with that. But there is also some things on the other side of it where, depending on the material you're going to be running, we have a really good all-purpose formula, which is, for high pressure delivery, but covers most metals or all metals. And then we have some that kind of really get granular. So if you're doing aerospace alloys, for example, we've got what we call our Tough Lube Extreme, which is really good on high nickel alloys and that sort of thing. But we generally recommend that you don't run a brass part with it because it's formulated in a way so that you get the better tool life off of your coating technology and everything like that. But it's not good for yellow metals. So a situation like that is kind of a special situation. But yeah, there's a good range of options that are out there, and generally you want something specifically made for Swiss machines because there's also generally a viscosity requirement. And if you're going to be running things through orifices on your tools that are down in the range of, geez, this jet right here is probably somewhere around 20 thousandths or so, you need something that's low enough viscosity that the pump can push through everything, whether you're doing internal coolant drills, through coolant end mills, or more importantly, all your turning tools with all their fancy coolant through jets that you want to be able to take advantage of. You got to run the appropriate viscosity. So again, GenSwiss sells a range of these that they kind of really walk that line of the viscosity of being light enough, but also heavy enough in that they're not getting into places they shouldn't be. It's specifically formulated for this type of the type of operations you're going to run on a Swiss, as well as the equipment itself. We really like to tout the fact that our oils generally protect the equipment the same way that you would protect the internals of the engine of your car. So I've said multiple times now that we have a brand new Citizen machine sitting on our shop floor at GenSwiss. We run our oil in it, of course. In the internals of it, you open that operator door, it looks like the day it came off the showroom floor still. There's no buildups on anything like that, so the window's still crystal clear, and it's not affecting like the paint or anything like that. It looks showroom new still, and we've run many jobs over the last 6 months with it. So
Nice. Yeah, I'd be interested to try that out. We tend to just have Blaser in our oil room, but that sounds like something I'd be interested in trying.
Which is a good product.
Nothing against it. It works fine. I use it literally every day. But speaking of yellow metals and high pressure coolant, though, I've been sitting here staring at what I'll call Chekhov's cutoff tool here for this entire thing. What is its deal?
What do we got? This guy right here?
Yeah.
Oh, okay. You know what? I did get too excited and kind of glossed over this a little bit earlier. So this is the latest and greatest from our partners at Utilities, and actually this isn't even a product that's launched just yet. This is what we're calling our Evo Cool, and this is for cutoff and grooving. So it's similar to the Cut 5000 that we recently introduced in that it has an internal jet, and it's going to be really tough to see it here on the camera. See if I can get up close. We've got an internal jet on this blade that follows the carbide into the cut. So as we mentioned earlier, this pairs nicely with the L320's coolant through plate. We got the port right there that lines up, but now we've also got a replaceable jet here. So God forbid you do make some expensive noises. It's not expensive to replace this. You could put this module back in and be up and running again with a fresh internal coolant jet. And then, of course, we still have the traditional position of it up top for also controlling the chip. But the flank coolant jet is really where it's at these days. And the technology has advanced so much to allow us to be able to produce these tool holders that have that capability. So lathe guys have enjoyed this for a very long time. Swiss guys have not, and this is going to be one of the leading edge ones that hits the market. Probably sometime end of Q1, we'll have these in stock ready to go. So this was actually a prototype that I brought specifically to kind of tease and preview. This is the first time that we're getting it out there. We haven't talked about this with anyone else yet, so brought this along specifically for the MCC demo day.
Nice. Well, I appreciate you explaining that because that's been needling at me since I sat down this morning.
Well, when you and I first sat down and we're kind of going over this yesterday, and we're talking about, like, we weren't going to script anything. We're just kind of it's two guys who are sort of passionate about the product that they represent, just kind of having a conversation. Sometimes you get excited and you forget something. So I really appreciate bringing that up, Vince.
Yeah, no problem at all. Do we have any further questions, or is that a wrap, or?
There was another question separately about MC data page, so I can maybe reloop the MC data videos.
Sure.
Yeah, bring up the MC data again. The question was what about
Specifically about custom tool holders.
custom tool holders?
So
That's near and dear to me.
Right, yeah, well, here's where we get into good news, bad news territory. So the good news is you can use custom holders. If we can go to the MC data page that shows the holders, there is one specific frame I'm hoping to show where during the tool selection part, where we can see the list on the right side of the screen. And what you'll see when we bring up that screen is there will be an option called Free Tool, right? So basically what you would do is you'll see a T-Pat button in the soft keys when he calls up the screen, or insert. Actually, it's on the prep page. You'll see the T-Pat button. So what you would do is if you had a custom holder, right, you would go and you would set up its data in that tool pattern button, and then you would tell it all its dimensions, and then when you go to MC data, yeah, stop that. Right there, so you see the ATC button in the middle, one to the right and one up is TPAT. So you would hit that soft key, you would define your holder's dimensions there, where all the centers of the pockets were, the index points, etc. And then when you go to MC data, the options on the blocks that support it, you'll see a free tool selection. And so if you you pick free tool, and the free tool pattern that you've designated in that screen will, then be what is used as far as the index positions and things like that goes. Now, the only bad news is, I spoke before about how if you have everything set up in MC data, the machine knows where all its collision zones are, and Citizen Steel will not hit Citizen Steel. The unfortunate trade-off is that a free tool is not Citizen Steel. So we cannot make those guarantees about anything you're putting in the free tool pockets. That's, you can put it in, you can implement it, and the tool pattern that you define will allow you to use it in our machine, but the system doesn't necessarily account for every third-party option, every custom. I mean, you guys are machine shops, you can make whatever gang you want, but we can't account for what you might do in our software up there.
Of course, you've also got other modes of checking the program and clearances as well, which you
Right.
can still run through like jog wheel and go through blocks and do it that way as well. So
Absolutely, it's not unsafe, but it's not going to have the same support that
Yeah.
that you get. Yeah. There's also some real nitty gritty about G630 and how that interfaces with it, but that's really like drilling down in advanced apps, technical aspects of how the code works. Do we have any other questions from the internet or the room? All right, well, seems like the well is run dry.
We'll open up to the room.
Give us the definitions and call it the sitting out front then.
Oh, well, yeah, this is just for anyone unfamiliar with the Swiss concept. Just to visualize what you got. You have your main spindle collet, obviously, and then your guide bushing is going to be, so you have a fixed headstock machine as your conventional lathe, but a sliding headstock, as the Swiss is also known. The guide bushing will stay stationary, but then your spindle is what's moving, and your tools are going to always stay here, at Citizen Zero, making the cut as it goes. So, that's kind of what I mean. We talk about not pulling out of the guide bushing. If you only have about 800 thou of land, 3/4 inch of land in there that will actually support your part. So if you retract too far, or if you do your OD before you do your ID, and as a consequence retract too far, you fall out, and then you try to go back in, and you end up with problems. At best you ruin that part. But probably, if you crash it hard enough, you could, just do some damage to the machine or the material, depending on what you're running.
but that whole setup is what makes a Swiss machine a Swiss machine.
Exactly. That is the Swiss concept right there.
Are we using standard collets and guide bushings for this particular part that we're running for the demo?
Yes, we are, but that brings up another interesting point about a lot of the Citizen line these days. Is almost all of them, well, actually all the modern ones, some of the back in history less so, but all the ones coming out today have an option to upgrade the spindle size to, it varies based on the model. Like an L12 can go from an L12 to 16, so 4 millimeters, D25 to D32, 7 millimeters. So depending on where it starts, you can increase the capacity of the machine to a substantial degree, and then, that's not stock collets and guide bushings, but for that platform, but the option is there, and you can get a little bit more, diameter out of pretty much any of your modern Cincoms these days.
Yet another example of flexibility. So I think back to way back when I first started, and things were a lot more rigid. It was a high volume, high production kind of a situation, and now people are able to use these things for shorter runs thanks to advancements like that, or make an investment and be able to upgrade it down the road, and you can get a little bit more capability. So
yeah,
Yep.
and more versatility as well. Like, you can always go back down, if you need to go back to smaller work,
Sure.
and not overkill it. And you can always have that ability to squeeze. And it's a simple changeover too. It's literally just swapping out the sleeve, and the kit comes with the spring and the bushing and all that you would need to swap out the sleeve. And honestly, the hardest part is swapping out the guide bushing housing. And if you do that even a time or two, you can get that
really
down to
good
about
at
a
it.
half hour. Yeah.
Yeah.
There was a question of maybe AGB.
AGB?
Yeah.
Well, it's funny that the AGB got brought up because halfway through planning this, actually between shooting and today, we put an AGB in the L320 that we're running today at the in the showroom. So the AGB is great for materials like the brass that we're running right now, where it's not necessarily going to be uniform and ground along the entire length of the bar. You're going to get hit high spots, you're going to hit low spots, and if you have your guide bushing really well adjusted, that could jam up or that could get extra loose depending on what where you are on the bar. And so what the AGB does is it's a system that uses a different kind of guide bushing that comes in 3 segments to hold that with air pressure, so that as it hits a high spot on the bar, it relieves a little bit and it clamps on the tighter parts a little bit, and it does that so that you can maintain that guide bushing rigidity even in some materials that varies a lot on the OD. Or softer materials sometimes that aren't necessarily, you're going to clamp on it and maybe you just dig into it. So the AGB is a little bit more gentle at handling things like that and handles things like the variance of the bar. But because of the collet geometry, so traditional guide bushing, I have about 3/4 of an inch, and as long as I don't pull all the way out of the guide bushing, I'm fine. Because the AGB is air pressure, you're limited now to only about 50% of that land, because once you get past that center point, it's got potential to like clamp on the side that's not supported by material. It's gonna, it's past that balance point, and the end of the bar acts almost like a fulcrum, and it just levers around it.
A is for adaptive.
Yes, A is for adaptive.
There is a question going back to the free tool, or the system tool in MC data.
The free tool pattern, yeah.
For Eric, he states that it reverses the direction of M80 and M81. Is there a way to change that on the program?
So that's a loaded question. So the question came that the free tool changes the direction of your live tool, basically your M80 or M81. Is there a way to change that? And the answer is well, to be honest, this is the first time I'm hearing of that, and there's so many variants that. There's so many reasons why that could be. It may be something about that specific machine that that whoever asked that question is running. Maybe there's some issue with the software, with that specific software on that specific machine, or so I'm not even sure if that's true on all the Cincoms or not. But I do know that in many cases, what does happen is with our holders, our spindles, the machines know what the gear train looks like, and so it knows, well, for this tool to spin forward, this tool next to it has to spin backwards, and so it alternates. So it may be a symptom of that on certain models of the machine. Maybe it's not properly doing that because you told it you have something different in there. As far as is there a way to reverse it? I'm sure that there's a way to do it. I don't know off the top of my head, but that's absolutely the kind of thing that if you call our service department with it, or you even just call the Jersey office and ask for me, Vince, I will do some research into parameters and find out if we can do some fun macro stuff to maybe make that change on the fly for you, so that when you're using free tool, it applies, and when you're not using free tool, it goes back to the way it was.
It's with the hobbing holder, but it is a very application-specific question. Maybe we'll leave it for
with the hobbing holder, yeah. So now we're getting into even more weird specifics and specialties.
Yeah, real specialty.
So now we're looking at a real narrow corner case. So yeah, it could absolutely maybe make that backwards on the hobbing holder specifically, because then we get into, well, which hobbing holder is it? Is it the 1-to-1 ratio hobbing holder or the 1-to-3 ratio hobbing holder? And at that point, it's a bit. That's going to be one that, to get a true answer, is going to take a little bit of research and a little bit of service, and
yeah, for sure.
Yeah, so sorry to whoever asked that, but unfortunately we don't just have an answer to that in the pocket to give you on the stream. But
we have our top men working on it.
Yeah, Yeah, we do.
Top men.
As soon as this wraps, the top men will be working on that immediately. And yeah, like I said, just call in or send an email to apps@mctz.com. That'll hit every applications guy, and someone competent will get on it because that's our entire team.
Awesome.
There's a question about if there is needed to be a warm-up time with the machine. We wanted to talk about our temperature sensors and go with
All right.
that. Yeah.
So the question was brought up about a warm-up time on the machine, and that so we do have on all the modern models thermal displacement control. The 635 control on the L5 that Scott cut his teeth on are the last generation that doesn't have that. But any time past that, you'll get, so basically the machine will compensate as it warms up. You know, the thermal characteristics will make the ball screw and some of the motors kind of change the way they behave, or, you know, literally shrink and enlarge the parts. You know how it is. You hold the part in your hand long enough, it'll measure different.
Yeah,
so,
exactly.
The machine compensates for a lot of that if it's properly set up. But unless you're in a really thermal shock heavy climate, you're unlikely to need to, or maybe if your tolerances are extremely minuscule, that you're seeing a lot of swing in your measurements from the time you start the machine to the time it's warmed up, then maybe in those conditions you would need to warm up the machine a little. You know, I have a couple customers that run like a half-hour warm-up cycle when they come in on Monday because the machine's been off all weekend, and so they run it, you know, on Monday mornings to get the machine ready. But in most cases you wouldn't have to do that. But yeah, there are absolutely contexts where you would want to, and there are times where, well, the machine does everything it can to prevent you from needing to do that and to make those adjustments automatically. But sometimes those adjustments need to be tuned. Those sensors are a service item, so, you know, sometimes they need to be replaced on an older machine. But
I could say a lot of the stuff that we use our citizens for is we're making some of our own products, the tie lock is being one of them. And our guys that are out there running the equipment all day, thermal stability is not a complaint that we hear from any of that. So that's also another good aspect.
And you guys are up in Arctic Massachusetts.
We sure are. Actually, the shop tends to be a little bit warmer than the office, so sometimes
I believe that. All the machines running.
Yeah.
They kick off some heat.
Yep.
Yeah, I hope that answered your question to your satisfaction. Is there got anything else?
Nothing else on chat.
Okay.
All right.
Well, I think that was a good hour or so presentation. Appreciate everybody for attending in person as well as online, and thank MCC for inviting GenSwiss to participate in this. This was a lot of fun, actually.
Yeah, I had a great time, and thanks for bringing all your cool new toys to show us and let us cut on the L3.
Absolutely.
You guys will be around if anybody wants to ask a question of just you.
Yeah, any of the in-person folks will
absolutely,
be
yeah.
hanging out here. Yep.
Yeah.
Okay.
If you can just announce, so there'll be a survey to send after the meeting online, so if you can answer that to help improve for the next conversation or next demo day, what you'd like to see more of, less of, things of that nature, that'd be great.
All right, I was just informed that you online people should stick around just long enough to answer a survey for us about how this went and what you liked about it, what you would like to see if we do more of these in the future, and when.
Yeah, it was a little bit different format that we were trying out just to see how the flow was and just see how it works. So yeah, it would be really good to get some feedback.
Yeah, absolutely. It would be much appreciated.
Very good. Well,
I think that's
nice
a wrap.
work.
Good one, Scott. Thanks for coming down.
Yeah.
All right.
Thank you, guys.
Bye, everybody.
Me too.
So for everyone in person, the